Welcome to the course CS213 Object Oriented Programming of the Kohat University of Science and Technology. This is lecture 23 of the course, and we will be discussing nested classes in the context of graphical user interfaces or graphical programming. The topics include the introduction to nested classes, the types of nested classes, for example, static, non-static, member classes, local classes, and anonymous classes. The relevant reading material can be found in chapter 12 of the reference book as well as the Java tutorial that you can find online. Nested class is a class defined inside another class is called a nested class. Some classes only make sense in the context of another enclosing class. They may not make more sense independently, they make only sense when used inside another class or when they are enclosed inside another class. For example, a GUI event handler cannot exist by itself. Only in association with a GUI component it handles events for. For example, the action listener. So when we interact with a GUI component, the handler for that particular event is related to or associated with that component alone, and we can include a nested class to handle the event of that component. We use nested classes to reflect and enforce the relationship between two classes. A nested class can be declared as static called static nested classes, non-static called inner class. So these are the examples of nested classes, inner classes, and static nested classes. The inner classes have further types like the inner classes, method local inner classes, and anonymous inner classes. A typical example of an nested class is we have an outer class and we have an inner class inside the outer class, as we can see over here. So this is our regular class, and this is an inner class defined within our regular class. Inner class has complete access to the fields and methods of its enclosing class, including those declared private. So it has access to all of the methods and the fields of the class that is enclosing the inner class. And if you want to see how it is named, or the class file for this is created as my regular class separated by this dollar symbol, my inner class. This is how our class file for the inner class is created. Why do we need to use nested classes? It is a way of logically grouping classes that are only used in one place. For example, if a class is useful to only one other class, then it is logical to embed it in that class and keep the two together. For that is the helping classes or helper classes that are only used where they are needed. There are helper methods that are private to the class, or the method that are private to the class where they are needed and are not used from outside of that class. It increases encapsulation. Encapsulation or data hiding is something where we want to protect our data from outside access. Consider two top-level classes A and B, where B needs access to members of A that would otherwise be declared a private. By hiding class B within class A, A's members can be declared private and B can access them. In addition, B itself can be hidden from the outside world. We have seen associations or relationships between the classes, for example inheritance, but in inheritance we are not able to directly access the private members of the superclass. Nested classes can be a way where we can access the private members of a class that encloses a nested class. It can lead to more readable and maintainable code. Nesting small classes within top level classes places the code closer to where it is used. Static nested classes. If you want to make objects of a nested class type independent of objects of the enclosing class type, you can declare the nested class as static. Static variables or static methods, if you remember, do not need to be dependent on the object of the class where they have been declared to be accessed. They can be directly accessed through the name of the class. So if you want to make objects of a nested class type independent of objects of the enclosing class type, you can declare the nested class as static. It can access static members and variables of its outer class even if they are declared as private. It cannot refer to any instance members, so it can only access the static members and variables. Is associated with its enclosing or outer class, behaves as any static member of the outer class. May be instantiated or accessed without an instance of the outer class, as is the case with the any other members of the class, the static members of the other class, where we can access them without the instance or object of the outer class. So we can have access to the static members of the outer class inside the static nested class, and the objects of from the static nested class can have access to the static members of the outer class, and the outer class has access to the nested class. Creating objects of the static nested class. You can declare objects of this nested class type independent from any objects of the outer class, and regardless of whether you have created any outer objects or not. So we do not need to create objects of the outer class to be able to create the objects of this static nested class. We don't need to create an object of the outer class like the other static member. So as we do not need to create an object of the class to access any static member of the class, similarly we do not need to create an object of the outer class to access or create objects for the static nested class. So if you want to create an object outside of the class from any other class, we can create it. For example, this is our nested class and this is the outer class, so we can access it or create an object for it using this syntax, that is the name of the outer class, the name of the class, name of the object, and then we declare the object for initialize the object for the nested class. Within the outer class itself, if we are creating an object of the static nested class within the outer class, then we can directly create the object of the class using the normal syntax. No access to instance members of the enclosing class or the outer class, so it can only access to the static members of the outer or enclosing class. So static inner class will have access to the static members of the outer class, and it may not be able to access this private member. So this is the inner class or the inner static class, public static class, my static inner, and this is the outer class. And if we create objects of this inner class, we are only able to access the static members of the outer class. The enclosing class outer class has full access to the static nested class. So the enclosing class will have access to the static and non-static members of the static inner class. So again we have the outer class with these variables. One of this is static variable, and then we can create an object of this class, create an instance of the static nested class, and we can access the private members of the static inner class. As we can see that we can not only access them, we can print the output of those variables that are inside the static inner class. So the outer class or the enclosures class has full access to the static nested class. As you can see, when this method is called, this is the output that we should get. The static nested class can access to the static members of the outer class. It can only access the static members of the outer class, but it cannot access to the instance members. So here in this case, for example, in this instance method, we can only access the static count from the outer class. If we are trying to print this x and this x is not static over here, then the value that we will be getting as an output is the value for this x, that is 2. You can try this code, and if you get the output should be this 2. And we have again the static end count is equal to 20 over here, and we have the static end count is equal to 10 over here. If we print the value for count, this will print the value 20 over here. But if we want to print the value of the outer count, we can do that by using this syntax. This is the name of the class, and we can access the static member of a class with the name of the class, as we can see over here. And we can also have access to the static method of this class. This will have access to the static method of the enclosing class. Inner class is a nested class that is associated with an instance of its outer class is known as an inner class. So the non-static nested classes can be called inner classes. And the syntax of an inner class is public class. For example, we have an outer class, and then we can enclose a non-static nested class inside the outer class that is called the inner class. So it can be shown as, for example, this is our outer class, and we enclosed our inner class inside the outer class. These are completely enclosed inside the outer class. These are non-static and can be of type member classes. So a member class is defined within the body of a class, as we can see over here. Then we can have local classes. A local class is a class defined within a method. Then we can have anonymous classes. A local class is declared implicitly by creating a variable of it. As we can see in this hierarchy, we have nested classes, and a nested class be a static nested class, or it can be an inner class. Then an inner class can be an inner class, it can be a local inner class, or it can be an anonymous inner class. An inner class can be called like a member class that is defined within the body of a class, like this one. A method local class or a local class can be a class defined within a method in a class. And then we have anonymous classes. These are not named, but we can create object or declare them implicitly by creating a variable of these classes. Member classes, if we want to define a member class is not declared static. A member class is defined within the body of a class. The rules for member classes are: member classes cannot declare static variables and methods. So we need to remember that a member class cannot declare static variables and methods. The member class has access to all instance and class variables and objects of the outer class or any other inner classes, including members declared private. So member class has access to all the instance and variables of and objects of the outer class, and any other classes if there are in the outer class, it has access to all the members including the private members. The outer class has access to all the variables and methods in the inner class. So if we have an outer class, then we have a class member inside the outer class. Member class is an instance of an inner class is effectively inside an existing instance of the outer class. As we can see over here, the inner class has access to the static members of the outer class, and inner class has access to all the methods and variables associated with the instance of the outer class, including members with the private access modifiers. So it has access, basically it has access to all the members of the outer class. It can be said that an instance of an inner class is effectively inside an existing instance of the outer class. So these are objects of the outer class, and these will have the same value for the objects of the inner class. Creating objects of the inner class. Every instance of an inner class is linked to the enclosing instance that creates it. For example, these are linked to the objects of the outer class. If we are creating an object of the inner class within the outer class itself, then we can use this syntax. We create directly with the name of the class, and if you are creating them outside of the outer class or in other classes, then we can only create them with the help of the object, or with the linking them with the objects of the outer classes. So we have this outer object of the outer class, and then if we want to create an object of the inner class, we can link this object of the inner class with the object out of the outer class. So this will now be linked with the obj object of the outer class. More than one inner instance can be associated with its enclosing instance, so we can create multiple objects of the inner class and associate those objects with the objects of the outer class. For example, we have an outer class that has a member class. So we have one object and we have another object, and we can have, like in this case, we have two objects of the outer class associated, and we have associated two objects of the inner class with this object. Accessing methods and fields and member classes. The enclosing class has full access to the member class, all instance members. So we create a new instance of the member class. This is our member class, and we can create a new instance of the member class, and we can access the variables of the member class in our outer class. No static variables should be defined inside the member class. Should note that you cannot create inner class objects without first creating an outer class object, and this is where it is different from static nested classes, where we were able to create objects of our inner classes without the object of our outer class. Here in this case, we cannot create inner class objects without first creating an outer class object, and this is the output that we will get using this statement. Accessing methods and fields. The member instance can access to all instance and static members of the outer class even declared as private. So it has access to all the members, the instance and the static members of the outer class, as we saw previously in our previous slides. This is, for example, an outer class, and we want to access the member of the outer class over here, the members of the outer class were over here, so we can access both the private member and the static member outer of the outer class. As we can see over here, we can print both the values of the inner class itself and of the outer class as well. What is the output of the following program? You can run the program and try to see what should the output of this program be.